Hello everyone, welcome to Premier Math. Today we are going to discuss some important time and work questions based on previous year questions. We will be solving these questions using speed matrix. So let's start our session. Our first question is, A and B can do a piece of work in 15 days. B and C can do the same work in 10 days. A and C can do the same work in 12 days. Time taken by A, B and C together to do the job is, here A and B can complete a work in 15 days and B and C can complete the same work in 10 days and A and C can complete the same work in 12 days. Now A and B, B and C, A and C all are doing the same job. So take the LCM of 10, 15 and 12. Here LCM of 15, 10 and 12 is 60. Now 15 goes 4 times in 60, 10 goes 6 times in 60, 12 goes 5 times in 60. Now concept of this diagram means total work is 60 unit. Total work is 60 unit and efficiency of A and B is 4 unit. That means A and B can do 4 unit of work in a day. Efficiency of B and C is 6 unit. That means B and C can complete 6 unit of work in a day. Efficiency of A and C is 5 unit. That means A and C can complete 5 unit of work in a day. Here add A, B, B, C, A, C together. There is 2A, 2B and 2C. That means 2 into A plus B plus C. Efficiency is here 4 plus 6 plus 5. AB efficiency 4, BC efficiency 6, AC efficiency 5. If you add all these together, there is 2 into A plus B plus C, which is equal to 15. That means efficiency of A plus B plus C is 15 by 2, which is equal to 7.5 unit. So here total work is 60 unit and efficiency of A, B and C is 7.5 unit. That means time taken by A, B, C together to complete this 60 unit work is 60 by 7.5, which is equal to 8 days. So option C is your answer. A, B and C can complete a work in 10, 12 and 15 days respectively. A left the work 5 days before the work was completed and B left 2 days after A had left. The number of days required to complete the whole work is, here A can complete a work in 10 days, B can complete the same work in 12 days and C can complete it in 15 days. Now work rate is same. Take the LCM of 10, 12 and 15. LCM is 60. That means total work is 60 unit. 10 goes 6 times in 60, 12 goes 5 times in 60, 15 goes 4 times in 60. That means A has 6 unit efficiency, B's efficiency is 5, C's efficiency is 4. The question clearly says that A left 5 days before the work was completed. Let X be the total number of days to complete this work. Then A left 5 days before the work was completed. That means for X minus 5 days, A, B and C were working together. Then A left, that is remaining is 5 days. But B left 2 days after A had left. That means after A left, B and C were working together for 2 days. But B left 3 days before the work because B only worked for 2 more days after A had left. So the remaining is 3 days. Now A and B left, remaining is C. So C alone worked for 3 days. Now here efficiency of C is 4. That means work completed by C in this 3 days is 3 into efficiency of C is 4. So 12 unit is the work completed by C in 3 days. And work completed by BC in 2 days is 2 into efficiency of B and C is 5 plus 4, 9 unit. So 2 into 9, 18 unit. Now total work completed by BC in 2 days plus C in 3 days is 18 plus 12, 30 units. So remaining work is, total work is 60, remaining work is 60 minus 30, which is equal to 30 unit. This 30 unit work is completed by ABC. So ABC efficiency is 6 plus 4 plus 5, which is equal to 15. 30 by 15 is equal to 2. So 2 days ABC were working together. So ABC worked for 2 days. Now total number of days. Total number of days is equal to 2 plus 2 plus 3, which is equal to 7 days. So option C is your answer. ABC together worked for 2 days. BC together worked for 2 days. C alone worked for 3 days. Now total number of days is 2 plus 2 plus 3, which is equal to 7. You can do this in different way as well. Let X be the total number of days to complete this work. Then A left 5 days before the work, means A worked for X minus 5 days. And B left 2 days after A had left, means B worked for X minus 3 days, because 5 minus 2 is 3. And C worked for whole days, that is C worked for X days. Now 60 is the total work. That means 60 is equal to, total work is equal to work done by A plus work done by B plus work done by C. Here efficiency of A is 6. So 6 into number of days A worked is equal to work done by A. So 6 into X minus 5 is the work done by A, and efficiency of B is 5. So 5 into X minus 3 is the work done by B, plus efficiency of C is 4. So 4X is the work done by C, which is equal to total work 60 unit. 6X plus 5X plus 4X is 15X minus 6 into minus 5, 30. 5 into minus 3, 15, which is equal to 60. That means 15x is equal to 105. That means x is equal to 7 days. So option C is your answer. A can complete a piece of work in 10 days, B in 15 days, C in 20 days. A and C worked together for 2 days and then A was replaced by B. In how many days altogether the work was completed? Here A can complete a work in 10 days, B can do the same work in 15 days, C can complete the same work in 20 days. Now all are doing the same job, so take the LCM of 10, 15 and 20. LCM is 60. 10 goes 6 times in 60, 15 goes 4 times in 60, 20 goes 3 times in 60. Now, the concept of this diagram means 60 unit is the total work. A's efficiency is 6 unit, means A can complete 6 unit of work in a day. B's efficiency is 4 unit, means B can complete 4 unit of work in a day. C's efficiency is 3 unit, means C can complete 3 unit of work in a day. Here, question clearly says, first A and C work together for 2 days. Then A was replaced by B and B and C completed the remaining work. Here you can see efficiency of A and C in 1 day is 6 plus 3, 9 unit. Efficiency of A and C is 6 plus 3, 9 unit. And efficiency of B and C is 4 plus 3, 7 unit. Now A and C worked for 2 days. In 1 day A and C can complete 9 unit of work. In 2 days A and C can complete 18 unit of work. Right? So total work here is 60 unit. And work completed by A and C in 2 days is 9 into 2, 18 unit. Because in 1 day A and C can complete 9 unit of work. In 2 days A and C can complete 18 unit of work. So the remaining work is, total work is 60, completed work is 18. So remaining work is 42 unit. So this is complete. This is completed by B and C. So time taken by B and C to complete the remaining work. Remaining work is 42 unit and efficiency of B and C is 7 unit. So B and C will take 6 days to complete the remaining work. So total time taken by all these three is 2 days plus 6 days, which is equal to 8 days. So 8 days is taken to complete this work. Option D is your answer. A can complete a piece of work in 18 days, B in 20 days, C in 30 days. B and C together start the work and are forced to leave after 2 days. The time taken by A alone to complete the remaining workers. Here, A can complete a work in 18 days and B can complete the same work in 20 days and C can complete the same work in 30 days. Now all are doing the same job. So take the LCM of 18, 20 and 30. Here LCM is 180. Now 18 goes 10 times in 180, 20 goes 9 times in 180, 30 goes 6 times in 180. Now the concept of this diagram means 180 unit is the total work. Now A's efficiency is 10, B's efficiency is 9, C's efficiency is 6. That means A can complete 10 unit of work in a day, B can complete 9 unit of work in a day, C can complete 6 unit of work in a day. Now, here the question says, B and C started the work. B and C started the work and they worked together for 2 days. Then after B and C leave and the remaining work is completed by A. So we need to find out in how many days A completed the remaining work. Here, efficiency of B and C is 9 plus 6, 15 unit. That means B and C can complete 15 unit of work in a day. But here B and C worked for 2 days. That means in 2 days they completed 2 into 15, 30 unit of work. So the remaining work is 180 minus 30, which is equal to 150 unit, which is completed by A. And efficiency of A is 10 unit. That means the remaining work 150 unit is completed by A in 150 by 10, which is equal to 15 days. So option C is your answer. Here remaining work is 180 minus 30, which is equal to 150 unit. And time taken by A to complete the remaining work is 150 by remaining work by efficiency of A is 10 unit. So 15 days. A can do a piece of work in 20 days, B in 30 days. They work together for 7 days and then both leave the work. Then C alone finishes the remaining work in 10 days. In how many days will C finish the full work? Here, A can complete a work in 20 days, B can complete the same work in 30 days. Now the question says, A and B started the work and they worked together for 7 days. Then they left the work and the remaining work is completed by C in 10 days. So C only completed the remaining work. So we need to find out in how many days C can finish the full work. Here LCM of 20 and 30 is 60. So 60 unit is the full work. 20 goes 3 times in 60, 30 goes 2 times in 60. Efficiency of A is 3 unit, efficiency of B is 2 unit. So efficiency of A and B is 3 plus 2, 5 unit. That means A and B can complete 5 unit of work in a day. So A and B work together for 7 days. So in 7 days, work completed by A and B is 7 into 5 unit. In 1 day, A and B finish 5 units. So in 7 days, A and B finish 35 unit of work. So the remaining work is, total work is 60 unit, completed work is 35. So remaining work is 25 unit. and this 25 unit is completed by C in 10 days. So efficiency of C is work completed by C is 25 unit and time taken by C to complete the 25 unit is 10 days. So efficiency is 2.5 unit. That means efficiency of C is 2.5 unit here. So total work is, full work is 60 unit. So time taken by C to complete this full work is 60 by 2.5, which is equal to 24 days. So option C is your answer. Total work is 60 unit and efficiency of C is 2.5 unit. That is, C can finish 2.5 unit of work in one day. So 60 unit of work will finish in 60 by 2.5, which is equal to 24 days. So option C is your answer. X can do a piece of work in 24 days. When he had worked for 4 days, Y joined him. If complete work was finished in 16 days, Y can alone finish that work in how many days? Here X alone can finish a work in 24 days. And here X alone worked for 4 days. After this 4 days, Y joined him. That means X and Y were working together after this 4 days. And the work is finished in 16 days. That means X and Y were working together for 16 minus 4 days, 12 days. Now, X can complete a work in 24 days means here in 24 days, one full work is completed by X. But here X only worked for 4 days. X alone worked for 4 days. That means in 4 days, how much work is completed? 1 by 24 into 4, which is equal to 1 by 6 work is completed in 4 days by X alone. Now, if 1 by 6 work is completed by X in 4 days means the remaining is 1 minus 1 by 6, which is equal to 5 by 6 work. So 5 by 6 work is completed by X and Y in 12 days. So 5 by 6 work is completed by X and Y in 12 days means one work is completed by X and Y in how much days? 12 into 6 by 5 days, which is equal to 72 by 5 days. So X can complete a work in 24 days and X and Y can complete the same work in 72 by 5 days. Now the work has equaled. Here 1 by 6 work is completed in 4 days by X alone and 5 by 6 work is completed by XY in 12 days. Here work is not equal, but here work is equal. So take the LCM of 24 and 72. Here LCM is 144. Now 24 goes 6 times in 144, 72 goes 2 times, but this is 72 by 5. So 72 by 5 goes 10 times in 144. Now concept of this diagram means 144 is the total work and X efficiency is 6 and XY efficiency is 10. Efficiency of X is 6 and efficiency of Y will be 10 minus 6, which is equal to 4 unit. That means Y can complete 144 unit of work in 144 by 4 days. That is equal to 36 days. So option C is your answer. Now this question can also do in different way. That is, let's consider efficiency of X as 1 unit. That means total work will be 24 unit because X can complete one work in 24 days. That means if efficiency of X is 1, then total work will be 24 into 1, 24. So here X worked for how many days? 12 plus 4, 6 days. So work completed by X. Work completed by X is equal to 12 plus 4, 16 unit. Then remaining work is, total work is 24 work completed by X is 16. So 24 minus 16, 8 unit. Then efficiency of Y will be remaining work is 8 units. So 8 divided by this 8 unit is completed by Y in 12 days. So 8 by 12 is the efficiency of Y. So which is equal to 2 by 3. If efficiency of Y is 2 by 3, then time taken by Y to complete this 24 unit work is 24 by efficiency of Y is 2 by 3, which is equal to 36 days. So you can also calculate this way. If 6 men and 8 boys can do a piece of work in 10 days and 26 men and 48 boys can do the same in 2 days, then time taken by 15 men and 20 boys to do the same type of work will be. Here 6 men and 8 boys can do a job in 10 days and 26 men and 48 boys can do the same job in 2 days. Now the work is same. So equalize it. That is 6 men plus 8 boys can do a job in 10 days and the same work can be done by 26 men and 48 boys in 2 days. Here we are using the formula M1 D1 by W1 is equal to M2 D2 divided by W2. That is M1 is equal to number of men, women or children. D1 means number of days, months or years. W1 is the work rate. So here 2 goes 5 times. 6 into 5 30. Here 26. So 4 men is equal to 48 boys minus 40 boys. 8 boys. Which is equal to 1 man is equal to 2 boys. So as per this, 1 man is equal to 2 boys. 1 man can do 2 boys job. Here our question is asking us to find out time taken by 15 men and 20 boys to do the same job. Here 15 men and 20 boys means 15 into 2 plus 20, which is equal to 50 boys. So apply 1 man equal to 2b in the first equation as well. That is 6 men plus 8b. 6 men is equal to 6 into 2, 12 plus 8 boys. That is equal to 20 boys. So 6 men plus 8 boys is equal to 20 boys. Then as per the question, 20 boys can do a job in 10 days. Then our question is, in how many days 50 boys can do the same job? That is, 20 boys can do a job in 10 days. Then 50 boys can do the same job in how many days? So B cancel. Now 200 by 50 is equal to 4. So number of days taken by this 50 boys to complete this job is 4 days. So option B is your answer. So D is equal to 4 here. If 10 men or 20 women or 40 children can do a piece of work in 7 months, then 5 men, 5 women and 5 children together can do half of the work in. Here 10 men or 20 women or 40 children can do certain work in 7 months. Then we need to find out 5 men plus 5 women plus 5 children can do half of the same work in how many months? Here from this statement 10 men is equal to 20 women is equal to 40 children. Because 10 men or 20 women or 40 children all are doing the same work in same duration. So this implies that 10 men is equal to 20 women means that 1 man is equal to 2 women. 10 men is equal to 40 children means that 1 man is equal to 4 children. And 20 women is equal to 40 children means that 1 woman is equal to 2 children. Now 5 men plus 5 women plus 5 children. I will convert it in terms of women. 5 men means if 1 man is 2 men, 5 men is 10 women plus 5 women plus 5 children. If 2 children is 1 woman, 5 children is 5 by 2 women, which is equal to 17.5 women. I will convert it as 35 by 2 women. Now, if 20 women can do one work in 7 months, then 35 by 2 women can do half of the work in X months. Now 7 goes 5 times in 35. 1 by 2 cancel. Now X is equal to 20 by 5, which is equal to 4 months. So option B is your answer. Here I am using the formula M1 D1 by W1 is equal to M2 D2 by W2. A company employed 200 workers to complete a certain work in 150 days. If only 1/4 of the work has been done in 50 days, then in order to complete the whole work in time, the number of additional workers to be employed is, here 200 employees completed 1/4 of the work in 50 days. Then 200 plus additional number of employees should complete 3/4 of the work. That is 1 minus 1/4 is 3/4. 3/4 of the work in 150 minus 50 days. That is 100 days. So this implies that here 1/4 cancel. 0, 0 cancel. Now 2 into 50 is 100. 100 into 3, 300. 300 is equal to 200 plus X. That means additional number of employees is X is equal to 300 minus 200, 100. So option A is your answer. A contractor was engaged to construct a road in 16 days. After working for 12 days with 20 workers, it was found that only 5/8 of the road had been constructed. To complete the work in stipulated time, the number of extra workers required is, here only 5/8 of the road has been constructed in 12 days. So 5/8 of the work completed in 12 days with 20 workers. Now the remaining work is 1 minus 5/8, which is equal to 3/8. So 3/8 of the work should be completed in, remaining days are 16 minus 12, so 4 days. So 3/8 of the work should be completed in 4 days with 20 plus X extra workers. Now this implies that 1/8 cancel. 5 goes 4 times in 20. 4 goes 3 times in 12. Now 3 into 4 into 3 is 3 into 4 12. 12 into 3 36. So 36 is equal to 20 plus X. That means number of extra workers X is equal to 36 minus 20, 16. So option D is your answer. Now here I am using the formula M1 D1 by W1 is equal to M2 D2 divided by W2. Two pipes A and B can fill a tank in 24 minutes and 32 minutes respectively. If both the pipes are opened simultaneously, after how much time should B be closed so that the tank is full in 15 minutes? Here A can fill a tank in 24 minutes and B can fill the same tank in 32 minutes. Now, both are filling the same tank of same capacity. Now, take the LCM of 24 and 32. LCM here is 96. 24 goes 4 times in 96, 32 goes 3 times in 96. Now, the concept is 96 unit is the total work. That means 96 unit is the capacity of tank. And A's efficiency 4, B's efficiency 3. A can fill 4 unit in a minute, B can fill 3 unit in a minute. Now, we have to find out in how much time should B be closed so that tank should be filled in 15 minutes. So here tank should fill in 15 minutes means that A should work for 15 minutes. So A should work for 15 minutes. That means work completed by A in 15 minutes is 15 into efficiency of A 4. So 15 into 4 is equal to 60 unit. Now work completed by A is 60 unit means that remaining workers total work 96 minus work completed by A 60, which is equal to 36 unit. That means this 36 unit should be completed by B. That means time taken by B to complete this 36 unit of remaining workers, 36 divided by efficiency of B is 3. So which is equal to 12 minutes. So option A is your answer. If two pipes function simultaneously, the reservoir is filled in 12 hours. One pipe fills the reservoir 10 hours faster than the other. How many hours does the faster pipe take to fill the reservoir? Here, time difference between both this pipe to fill the reservoir is 10 hours. That means if faster pipe take X hours to fill the reservoir, then slower pipe must take X plus 10 hours to fill the reservoir. Time difference here is 10. That is slower pipe take 10 hours more than the time taken by faster pipe. The question clearly says that if both the pipe work together, it will take 12 hours to fill the reservoir. That means LCM of X and X plus 10 should be a multiple of 12. That is here LCM of X and X plus 10 is 12X. Now, from the option it is clear that difference between 20 and 30 is 10 hours and difference between 35 and 45 is 10 hours. Now, if I take 35 and 45, LCM of 35 and 45 must be a multiple of 12, but it is not. So, option C and D are eliminated. Now, if I take A and B, that is, let's take faster pipe take 20 hours to fill the tank and slower pipe take 30 hours to fill the tank. Now, difference is 10 here. Now, take the LCM. LCM of 20 and 30 is 60, which is clearly a multiple of 12. Now, 20 goes 3 times in 60, 30 goes 2 times in 60. Now, if they work together, if both of these pipes work together, they will take 60 by efficiency of faster pipe and slower pipe is 3 plus 2, 5 unit. So, 60 by 5, 12 hours. So, if they work together, they will take 12 hours to fill the tank. That means faster pipe take 20 hours to fill the tank. So, option A is your right answer. Three pipes A, B and C can fill a cistern in 6 hours. After working together for 4 hours, C is closed. A and B fill the cistern in 4 hours. Then, find the time in which the cistern can be filled by pipe C. Here, A, B, C first work together for 4 hours. Then C is closed and remaining work is completed by A and B in 4 hours. Let us consider total work as 6 unit. Then efficiency of A, B and C together is work completed is 6 unit divided by time taken to complete the 6 unit of work is 6 hours. So 6 by 6 is equal to 1 unit. Now, work completed by ABC together in 4 hours is 4 into efficiency of ABC together is 1 unit. So, 4 unit is the work completed in 4 hours. Then remaining work completed by A and B together is total work 6 unit minus completed work by ABC is 4 unit. So remaining work is 2 unit. Now efficiency of A and B is work completed by A and B is 2 unit divided by this 2 unit work is completed in 4 hours. So 2 unit by 4 hours, which is equal to 1 by 2. So efficiency of A and B together is 1 by 2. And efficiency of ABC together is 1 unit. Then efficiency of C is efficiency of ABC together is 1 unit minus efficiency of A and B together is 1 by 2 unit. So remaining efficiency is 1 by 2 unit. So efficiency of C is 1 by 2 unit. Then time taken for C to complete this 6 unit work is 6 divided by efficiency of C 1 by 2, which is equal to 12 hours. So option B is your answer. A tank has a leak which would empty it in 8 hours. A tap is turned on which admits 6 liters a minute into the tank, and it is now emptied in 12 hours. How many liters does the tank hold? Let's check. Here, if this is the tank, this tank has a leak, and this leak will empty water in this tank in 8 hours. If X liter is the amount of water present in this tank, this X liter will empty in 8 hours. Now, a pipe is turned on in this tank, and this pipe will fill 6 liters of water in a minute into this tank. So in a minute 6 liters filling means in 1 hour 6 into 60, 360 liters of water is filling by this pipe into this tank. Now after turning on this pipe, this leak will take 12 hours to empty this tank. That is, in 12 hours already there is X liter of water is present in this tank, and in 1 hour 360 liters filling by this pipe into this tank. So in 12 hours 12 into 360 liters of water is filling by this pipe. So in 12 hours X plus 12 into 360 liters of water is emptying by this leak. In 8 hours X liters emptying. In 12 hours X plus 12 into 360 liters emptying. Here time difference between 12 and 8 is 4 hours, and amount of water emptying is, the difference between the amount of water emptying is X cancel, 12 into 360 liter. 12 into 360 liter means here 360 into 10 is 3600, 360 into 2 is 720. So total 4320 liter. So in 4 hours 4320 liters emptying by this leak. So in 8 hours, how much amount is emptying by this leak? In 4 hours, 4320 liters emptying by this leak. So in 8 hours, how much liter is emptying? 4 into 2 is 8. So 4320 into 2 is 8640 liter. So option C is your answer. So X here is 8640 liter. So in 8 hours, 8640 liters emptying. Initial water present is X, and which is equal to 8640. A tank is normally filled in 8 hours but takes 2 hours longer to fill because of a leak in its bottom. If the tank is full, in how many hours will the leak in the bottom of the tank empty half of the tank? Let us consider a filling pipe is filling this tank. So this pipe takes normally 8 hours to fill this tank. But when a leak present in the bottom of the tank, the same pipe take 10 hours to fill the same tank. Now in both the cases work is same because this pipe is filling the same tank. So take the LCM of 8 and 10. LCM is 80. 8 goes 10 times in 80. 10 goes 8 times in 80. Now the concept is 80 liters is the capacity of tank. Without the leak, pipe can fill 10 liter in an hour, and with the leak, pipe can fill 8 liter in an hour. That means here efficiency of pipe is 10 and efficiency of leak is 2, because 10 minus 2 is 8. So here efficiency of leak is 2. Means that this leak can empty 2 liter of water in an hour. So time taken by this leak to empty half of the tank means work is half of 80, because full tank is 80, half tank means half into 80, 40 liter. Now time taken by this leak to empty this 40 liter is 40 liter divided by efficiency of the leak is 2. Now 40 by 2 is 20 hours. So option A is your answer. That is, in 1 hour leak can empty 2 liter. In 20 hour leak can empty 40 liter. That is half of the tank.